Alright, so let's talk about how to show single bonds. We are really drawing Lewis structures, and that is for covalent molecules, which are two nonmetals. So you will be sharing electrons, and you need to follow the octet rule, which says that all the elements want to have 8 electrons, except for hydrogen, which wants to have 2. Okay? So there's a couple of steps in this process. The first step that we need to do is we need to find the math, is what we're going to call it. So in the example that I want us to do CF4. Excuse me. In this example, we need to figure out how many electrons are involved in CF4. So how many valence electrons are being shared. There is 1 carbon and 4 fluorines in this molecule formula. If you go to the periodic table and you look at the valence electrons for carbon, you're going to count over the S and the P's, and so there's 4 valence electrons for carbon, and fluorine has 1, 2, 3, 4, 5, 6, 7. So in this example, if you do the math like that, you will be expected to have 32 electrons, which are 32 dots. When we're done, we're going to verify that we actually do have 32 dots in our picture. Okay? So the next step, we did step number 1. Step number 2 is we need to place the carbon and the fluorines in the correct location. So the first element goes in the center, and then you put the other elements on the 4 sides around it. If you have hydrogen first, it does not go in the center. But because we have carbon first, carbon goes in the center, and then we're going to place our 4 other elements around it. Step number 3, we need to now place a bond, which, if you remember, is 2 electrons, between each pair of elements. In this example, we're going to put a bond between each carbon and each fluorine represented in our picture. We now need to finish the octet. So we are looking to have 8 around everything except for hydrogen, which gets 2. We don't have hydrogen, so we don't need to worry about it. We are going to finish filling in our picture with enough dots on each fluorine so that we have 8 around it. So we will continue double checking. There's 2 here, 2 more, 4 more, and 6 more around it. That makes 8. And now we have 8 around this last one. Keep in mind, when you're making your dots, they need to be clearly made dots, and you should take the time to make them so that they look like it was intentionally put there and it's not just you bumped your pencil. Alright? We have 8 dots around every element, including the one in the center. The last step is to go back and verify our total number of dots. We were told, we did the math, we needed 32 electrons or 32 dots. So if we look at our picture, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. We now have 32 dots, which is what we were supposed to have in our molecule. This molecule can also be represented where you show the single bonds as a dash. When you do that, you may only change the dots into a dash for bonds. You may not do that for unshared electrons. The ones that are on the fluorine that are only on the fluorine may not be dots or dashes, they have to be dots. This molecule down here on the bottom is the same as the one in the center. It also has 32 electrons represented. Each line is 2 dots, so a line equals 2 electrons. They are both single bonds. You can change them depending on your own personal preference. Sometimes I prefer to have the lines. I think it makes it more easy to see. Sometimes having the dots is a better example. 4 or 5 steps. Do the math, place your elements in the right spots, put 2 electrons between each pair of elements, finish filling out the octet rule, and double check to make sure you have the right number of dots. There is another example. Remember, this is just single bonds. There is another example that I'm going to show you in another video where sometimes the number of dots you've drawn does not match. In that case, you have to do something a little different.